You believe the world works in a simple order. First, something happens. Then, something else follows. Cause, then effect. This idea feels so fundamental that questioning it feels dangerous. Without cause and effect, nothing makes sense. Decisions lose meaning. Responsibility disappears. But here is the unsettling possibility. The universe may not be built on that order at all. At the deepest level of physics, events do not always line up the way our intuition demands. Sometimes there is no clear first, no obvious because, only relationships that become ordered after the fact. And once you start taking that seriously, the idea that cause always comes before effect begins to quietly fall apart. So if cause and effect are not fundamental, what is the universe really doing underneath? Cause and effect feel unavoidable because they shape almost everything in your life. You push a door and it opens. You touch a flame and you feel pain. You make a choice and something happens because of it. From the moment you are born, the world teaches you this pattern. First comes the action, then comes the result. Your survival depends on recognizing this order. If you couldn't predict outcomes, you couldn't avoid danger or pursue anything meaningful. So your brain becomes extremely good at finding causes. It links events together automatically, often without you noticing. A sound happens, you look for its source. A problem appears, you search for what caused it. This habit runs so deep that we stop seeing it as a model. We treat it as reality itself. Language reinforces this belief. We ask why. We assign blame. We tell stories with beginnings, middles, and ends. Even time itself feels structured by causality. The past causes the present. The present causes the future. Without that chain, time feels directionless. So when physics suggests that cause and effect may not be fundamental, the idea feels wrong in a personal way. It doesn't just challenge science. It challenges how you understand responsibility, choice, and meaning. Because if causes do not strictly precede effects, then the clean narrative we rely on starts to blur. But here is the crucial point. Feeling inevitable does not make something fundamental. Causality works incredibly well at the scale of everyday life. It is a powerful approximation. The question is not whether cause and effect are useful. The question is whether the universe itself is truly built on that order, or whether we impose it after the fact. Here is where physics begins to quietly disagree with intuition. At the most fundamental level, the laws that describe nature do not contain a built-in direction of time. The equations that govern motion, forces, and interactions work just as well forward as they do backward. If you were shown a perfect recording of particles interacting and played it in reverse, the equations would not object. Nothing in the math would say, "This is wrong. This is deeply strange." Because cause and effect depend on order. The cause must come first. The effect must come later. But the core rules of physics do not insist on that sequence. They describe relationships, not stories. They tell you how quantities are connected, not which event must happen first. So where does the arrow come from? Why does the world feel directional if the laws themselves are not? At everyday scales, order emerges because of statistics. Large numbers of particles tend to settle into patterns that look irreversible. Spilled water doesn't jump back into a glass. Broken objects don't reassemble themselves. This creates the illusion that time and causality with it has a preferred direction, but this direction is not written into the fundamental rules. It emerges from complexity, from averaging, from probability. At the deepest level, physics does not say, this causes that. It says, these things are related, And that distinction matters, because if the laws do not enforce a strict sequence of cause then effect, then causality may not be a basic feature of reality. It may be something that appears only when many interactions are combined and viewed from a limited perspective. In other words, cause and effect might be a story that becomes useful at large scales, not a rule that governs everything underneath. And once that possibility is on the table, the ground beneath causality starts to feel much less solid. Let's run a thought experiment. Imagine observing a universe without assuming cause and effect. You don't ask what came first. You don't search for a reason. You simply watch events as they relate to one another. At first, this feels impossible. Your mind immediately wants to arrange things into a sequence. Something must cause something else. But try to resist that impulse. Instead of asking why something happened, ask only how things are connected. You begin to notice something strange. Some events seem to define each other, only when viewed together. The meaning of one depends on the outcome of another. Remove the outcome, and the cause no longer makes sense. Now consider a simple measurement. You prepare a system. You perform an observation. You get a result. It feels obvious that the preparation caused the result. But what if the result is not fully defined until the measurement occurs? What if the properties you attribute to the system only become real at the moment you look? In that case, what exactly caused what? Did the system cause the measurement outcome? Or did the act of measuring help define what the system was all along? From this perspective, cause and effect are not separate events. Linked by time, they are two sides of a single interaction, defined together, resolved together. Only after the interaction is complete do we tell a story where one comes first and the other follows. Causality becomes something we assign retroactively, a way of organizing events after they have already happened. Now take this idea further. Imagine two events that are strongly correlated but separated in time. You can describe one as the cause and the other as the effect. But you could also reverse the description without changing the observable facts. Nothing breaks. No prediction fails. Only the story changes. This suggests that causality may not be a physical chain pulling the universe forward. It may be a narrative tool, a way for human minds to compress complex relationships into something understandable. At the deepest level, the universe may not care which event you label as the cause. It may only care that the relationship holds. And if that is true, then cause and effect are not the foundation. They are the interpretation, a layer we add once the interaction is already complete, which leads to an unsettling thought. If causality is assigned after the fact, then the order we experience may be more about how we remember events than how reality produces them. This strange idea is not just philosophical. It appears naturally. When physics looks closely enough, at the quantum level, the universe stops behaving like a sequence of well-defined events. Before a measurement is made, systems do not always have clear, definite properties. They exist in a range of possibilities, not because we lack information, but because the information itself is not fully there yet. When a measurement happens, something resolves. A single outcome appears. Only then do we tell a story about what led to that result. But notice the subtle shift. The outcome feels like an effect. The preparation feels like the cause. Yet the physical description does not clearly separate them. The measurement is not just revealing a pre-existing fact. It plays a role in defining the fact itself. This makes causality harder to pin down, because if properties are not fixed until measurement occurs, then the past is not always as settled as we imagine. In some experiments, the way a system is measured determines how it must have behaved earlier. Change the measurement, and the description of the past changes with it. Nothing travels backward in time, in a dramatic sense. But the clean line from cause to effect starts to dissolve. What remains are correlations, strong, precise correlations that exist without a clear direction. Physics can predict these correlations perfectly, without assigning a strict cause and effect chain. And this is the crucial point. Quantum theory works without requiring causality to be fundamental. It does not say, this happens, therefore that must happen. It says, when this is observed, that will be observed too. The relationship is real. The direction is optional. At everyday scales, this ambiguity disappears. Interactions become irreversible. Outcomes become stable. Stories become clear, but underneath that clarity is a framework that does not insist on cause coming first and effect coming later. Instead, it describes a world where events are connected without being strictly ordered. And once that framework is taken seriously, causality begins to look less like a law of nature and more like a rule of thumb, useful, reliable, but not fundamental. At this point, causality begins to look different, not false, but not fundamental. It starts to resemble something else, a way of organizing experience. When something happens, the human mind automatically searches for a reason. We link events together because it helps us understand, predict, and feel in control. Causality turns a chaotic world into a narrative. First this, then that, because of this, therefore that. But narratives are not the same as mechanisms. A map is not the territory. Physics does not describe the universe as a story unfolding in chapters. It describes relationships that exist all at once. When we impose cause and effect, we are choosing a direction through a web of connections. That choice is not wrong. It is practical, but it is not required by reality itself. This is why different explanations can describe the same physical process without changing any predictions. One person talks about causes, another talks about constraints, another talks about correlations. All are correct. None are privileged. Causality feels fundamental because we experience time sequentially. Memory points one way, anticipation points the other. So we line events up and imagine the universe marching forward. But that march may be something our minds add after the fact. The universe may not be going anywhere. It may simply be a consistent pattern of relations that we interpret as change. From this perspective, cause and effect are not the engine of reality. They are the language we use to describe it. And once you see causality this way, a deeper question begins to form. If the universe does not rely on cause and effect to function, then what does it rely on instead? So cause and effect may not be the foundation. We thought they were. Not because the universe is chaotic, and not because anything can happen without reason, but because the deepest level of reality may not be organized as a sequence at all. What feels like a chain of causes and effects may be a pattern we recognize only after events have already settled, a way our minds impose order on relationships that exist together without a built-in direction. Causality works incredibly well in everyday life. It helps us survive. It helps us plan. It helps us make sense of experience. But usefulness does not guarantee fundamentality. The universe may not run on stories. It may run on consistency, constraints, and relationships that simply hold. And we tell causal stories afterward to understand what we see. So here's the question to leave you with. If cause and effect are not truly fundamental, and the universe does not require them to function, then what do you think is the deepest structure of reality? I'm genuinely curious to hear your thoughts.